In this lecture, we are talking about K-means clustering in Python. Clustering is a fundamental, unsupervised machine learning techniques used for grouping data points into clusters based on their similarity. K-means clustering is a popular and versatile algorithm often applied in various domains like customer segmentation, image comparisons, and anomaly detection. In this presentation, we explore the impl- implementation implementation of K-means clustering using Python, dividing into a core concept, step, and practical application. Here we go. First is understanding K-means clustering. Algorithm instance. The K-means algorithm aims to partition a dataset into K distinct cluster where K is a user-defined parameter. It starts by randomly select a K initial centroid which represents the center of each cluster. Then the algorithm iteratively assign data point to the closest centroid and recalculate the centroid based on newly assigned points. This process continues until the centroid stabilizes, meaning the data point no longer shift between clusters. Key concept uh, K-means clustering is an iterative process evolving these key components centroid, the center point of each cluster. A distance metric, a measure to calculate the distance between data points and centroid. Cluster assignment, assigning the data point to the nearest centroid. Centroid update, recalculating the centroid based on assigned point. The next is Python implementation of K-means clustering. Loading libraries. First, import the necessary libraries. Scikit-learn, a popular machine learning library in Python, provide an efficient implementation of K-means clustering. Second, preparing data, loading and pre-processing process of your data. This may involve scaling or transforming features to ensure they contribute equally to the cluster process. Next is initiating K-means. Create a K-means object. Specify the number of cluster. Fit the model to your data to perform the cluster operation. Next is analyzing the result. Obtain the cluster labels for each data point. Visualize the cluster using scatter plot or other suitable method to understand the grouping patterns. Next is choosing the optimal number of cluster. First, elbow method. The elbow method is a commonly used technique for determining the optimal number of cluster. This involves plotting the sum of squared distance inertia within each cluster against different value of k. The optimal k is often identified at the elbow of the graph where the inertia starts to decrease more slowly. The second, Silhouette score. The Silhouette score is another metric to evaluate the quality of clustering. It measures how similar a data point is its own cluster compared to other clusters. Higher Silhouette score indicates better defined cluster. Third is domain knowledge. Domain knowledge can also play a vital role in choosing K. Consider the nature of your data and accepted number of a cluster based on understanding of the problem. Our next topic is real-world application of K-means clustering, customer segmentation, image comparison, and anomaly detection. In customer segmentation, group customers based on their purchase history, demographic, and behavior. This helps business tailor marketing champions and provide personalized experience. In image comparison, compress image by representing similar color regions with a single color. This reduces file size while preserving essential image detail. And anomaly detection. In anomaly detection, identify outlier or unusual data points in a dataset. This helps detect fraudulent transactions, network intrusions, or equipment failure.